Hojjat Jafarpour has been a key player in the streaming SQL space for a number of years now. He's also a former colleague and a great friend. In today's episode, we talk about the beginnings of his work there with KSQL, what he's doing now with DeltaStreams, and kind of how streaming SQL and real-time analytics and real-time analytics databases, how all these things interact, what it means for them to be cloud native. We cover a lot. I'd love for you to listen in. Let's get started. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm very happy to be joined in the studio today by my friend and once and perhaps future colleague, Hojjat Jafarpour. Hojjat, welcome to the show.
Hi, Tim. Thanks for having me.
Great to have you here. Now, you are the founder and CEO of a company called DeltaStream. I want to talk about DeltaStream a little bit today. And you're also the original creator of KSQL, and that's where our professional history goes back to at Confluent. You're the engineer who built the original version of that. Is that right?
Correct. Yeah, it started in 2016, if I remember, and I think you joined 2017.
Yeah, that's before my time.
At that time, yeah, we worked a lot together because you were very kind to actually present KSQL for a lot of folks at that time.
Oh, yes. I gave many talks. I still remember the first talk I gave on KSQL and the demo that I threw together. It was, those are the days. So
good days.
I kind of, right. And by the way, like your t-shirt, that's a Real-Time Analytics t-shirt.
Oh yeah.
Real-Time Analytics
that is
Summit.
The one that I got from you guys. Yeah.
Very nice. So if you're just listening to the audio version, not watching the video, Hojjat is in fact wearing a Real-Time Analytics Summit t-shirt. So you can't really see mine. Mine's
very good quality t-shirts, I should add. And
aren't they great?
I strongly recommend folks to stop mid talks for the next one because not just because of t-shirts, it was a great summit. I really enjoyed attending and talking to folks there, and really looking forward for the next one.
That's what I like to hear. We're recording this in late August. This will probably air sometime in September, and the CFP may even be open by the time this airs. So off the top of my head, I can't remember the date, but it's coming soon. Anyway, I wanted to talk to you about, just stream processing and streaming SQLs and how they fit into the real-time analytics world. This is super relevant stuff, and that's your last 8 years of life. 7 years of life. You wrote KSQL, and now you've got a startup that's doing kind of a cloud-native streaming SQL. If I could just ask you, start with KSQL, go forward. How did that idea hatch? What were the issues? Tell us the story.
Just let me add something. It's more than 8 years. The funny story is that my PhD thesis back in grad school also was on publish, subscribe, and streaming. And I worked in a streaming company as an intern in 2009 called Troviso, that they were changing the Postgres engine to do stream processing on it. So it goes long time ago. Okay. But fast forward to around 2016. Yes, pre-Kafka. Fast forward to 2016, I had a chat with Neha Narkede, CTO of Confluent at that time, one of the co-founders of Confluent. And we were talking about how to have a SQL layer on top of Kafka to make stream processing easier. And that was the start of the conversation and me joining Confluent for building KSQL. So the idea was that Confluent just had KStream announced in March of 2015. Mm-hmm. A lot of interest because if you look at Kafka, at DeltaStream, we call Kafka or Kinesis and these type of systems as streaming storage system. Yes. And you have streaming storage. They don't do any processing, byte in, byte out, but in larger scale. So the next step would be, once you have these streams of data, what can I do to get the value as data comes instead of sending it to a batch system and processing it there? So systems like KStream, which were Java-based, JVM-based, they were kind of first steps towards that goal, to be able to process this data as it comes and get insight and value from it. But again, as you remember, Java or any other programming language, it kind of like makes it more difficult for broader audience to be able to get value from these type of systems. So natural next step was what's the most popular way to interact with data systems? SQL, broad community. Let's bring that SQL to streaming world. So that was the inception of KSQL idea that, as I mentioned, we were discussing. And I started the project in 2016 at Confluent when I joined. And for around a year, I was sitting in a corner building different aspects of the first iteration of KSQL, if you will. And the idea was that we already had a stream processing engine, KStreams or Kafka Streams. How can we kind of like make it more abstract, have a SQL layer, still take advantage of the KStream capabilities, but user doesn't have to learn and build applications in Java. They can build those applications in SQL, and we take care of everything under the hood. So that was the initial idea. And in 2017, if you remember, in Kafka Summit in San Francisco, we announced the availability of first version of KSQL. And we saw a lot of interest, a lot of interest from the community. And it gradually became one of the main offering of Confluent, both in Confluent Platform and Confluent Cloud, if you remember. And a lot of customers were using KSQL to kind of like take their Kafka to next level and not just move data around in real time, but also be able to process and analyze that data in real time.
I do remember that summit and that fateful night before and the preparing of the pre-recorded demo. And it was,
exactly.
That was good times. Good times.
Good times. Yes.
Yeah.
Good times.
So it seems like
I usually say it was a very good first step in movement towards stream processing.
Oh yeah. It I mean, any first step in a technology like that in looking back is going to look very primitive. I mean, it's like when if you have kids, your oldest child learns how to jump on one leg or something like that. You know, that's a toddler thing. And you think, oh my goodness, this is so sophisticated and balance and muscle tone and like all these things are coming together. Look at what this kid can do. It's amazing. And then, you know, when that kid's 12, the video of the hopping on one leg doesn't look so sophisticated anymore. But
Correct.
Developmentally, it is at the time, and the same thing with the first version. It was huge, exactly. And it really does seem.
And
natural.
You were part of that process, like
the
fact that you were going around and you were kind of our link to community to kind of like see the reaction from community, how people see this product. And one big conclusion was that there's a need for such system, regardless of what you need to use. People want such system. And that was a great way of seeing it.
Yeah. Anytime you try to invent a new storage layer or new data abstraction and you think, oh, we don't need SQL for this, usually after a few years, you come back around and realize you do. It's you know, it's like an angry 17-year-old leaving home and, you know, coming back in a few years thinking, oh, gee, my parents got smarter in the last 4 years. You know, we've seen that a few times in the last 10 or 15 years with attempts to get away from the relational model and SQL. SQL always comes back. So like, I'm sold. I think you're absolutely right there. And so it began. Bring us forward. Well, what in the spirit of this being the real-time analytics podcast, there's two things you can do, at least two things you can do in stream processing. There really is, I think, by analogy, kind of a transactional sort of stream processing, if you were to think in database terms, and in analytics form. So, you know, maybe you've got a stream of orders and you need to enrich them with customer data and create a new topic, you know, a streaming join. Mm-hmm. You can express that in SQL, and that's kind of a transactional thing, right? You know, you've got a stream in and a stream out, and people want to consume that stream out. But you've also got, you know, let's compute aggregates in real time and group things and that kind of thing. Another thing you can do. So which one of those I think kind of seemed to emerge in the history of KSQL? And as you tell that story, please bring us forward into DeltaStream and what you're doing now, but how did it get used?
Sure. I think initial use cases, or you could call KSQL as a stream processing platform.
Mm-hmm.
By stream processing, or you can also call it streaming analytics. We kind of like see this, they're being used interchangeably. And the idea was that you would, as you said, you just explained it, you read from these topics, transactions and user data, join them, enrich them, and usually you create new streams from these. So it's kind of like a notion of like you build multi-stage pipelines. You read some input, you do the processing continuously, you write back to an output. Now this output is available, another query can read it from and do another processing and write to another place. So mainly processing. And these processing, as you said, it's the continuous queries that read continuously from sources, process, and write continuously to sinks. Later on, we saw the need for going beyond that. And if you remember, we had this notion of push query, pull query at Confluent conversations that we had at that time. And the idea was that people not only want to do this processing, but there's also a need for this notion of like, what is the current value of, for instance, this aggregation, for instance, I'm computing, and window aggregations, or any of that type of stateful processing that we were doing.
Yes, and or an entity that's evolving over time, like getting upserted, and I want the current value of that thing.
Exactly.
So that's that. I've got a key, and I want you to get me the value of this thing. That
exactly.
Right.
And if you remember, since KSQL was based on Kafka Streams, Kafka Stream had notion of interactive queries that you could directly query the state for a given query or a given streaming job. So hence comes the notion of like pull query, that you can now query that state store and get the current value for a given key. And that became that notion of like pull push query. Here we call them streaming query for the push queries. That in DeltaStream we call them streaming query. You read continuously, write continuously. But the notion of pull querying, KSQL we call also snapshot, or snapshot query. You just want to query the snapshot of the state at that point. It's kind of like the same query that you would submit for a table. And it explicitly defines that notion of materialized view in databases, but this materialized view is being continuously updated. You don't have stale data. So hence comes this second part of stream processing, which would be, how can I build these snapshots or materialized views and keep them continuously updated? So in case of KSQL, you have that notion of pull and push, different types of query.
And you call those snapshot and streaming queries. Pull and push.
Streaming query or continuous query for the push queries. I usually like that term more. You can think about that push query in the KSQL context. We call them streaming or continuous queries.
Okay.
And in the case of like querying that materialized view or the state, these are like just normal queries that you would submit to a view or table. And the idea is that it's like you submit the query, you get the result. It's not a continuous query anymore. You get the result and you're done. But that result belongs to that snapshot or the timestamp that you submit that query. And if you submit it again, you may get a different result because the state has changed since the time that you submitted the previous query.
Got it. Sorry to interrupt with that, but I heard those terms and I have to say I like those better than pull and push. As you know, that was always controversial. So
that was always controversial. Actually, at that time also, I liked continuous query better, but we settled on pull and push had like a nice pull and push type.
There's a symmetry to them. Yeah.
Symmetry there.
Yeah, but also kind of from the perspective of the advocacy team, those are new terms to introduce and new concepts. There's already new concepps all over the place here, and now there's these new words, and so Anyway,
and also you had like a pull request and stuff like that. It can easily, people can think about like, pull
heavily overloaded.
And overload words. But fast forward to KSQL DB, that we have these continuous queries, plus we also have these pull queries that you can query the state. But again, these are all built in the same platform, and the same platform. Now imagine if you are building a platform for on-prem, and if you want to also provide it on cloud, now you're using it in both environments, right? So this was kind of like a trigger for myself to think about like, what if we wanted to build the next generation of stream processing systems?
Okay.
And in that case, we had two options. We had option of like building something similar to KSQL or other systems that you see, for instance, Flink, Spark Streaming, that you run it both on-prem and on cloud. You run quote unquote managed version of these. But
Yes.
what if we just build for cloud? If we don't care about on-prem, we say that okay, we give up on-prem and we
Mhm.
just build on cloud. How can we make it simpler, make it easier, and take advantage of the things that cloud offers to provide easier way of using these type of systems for
Yeah.
our users? So that was the trigger of building DeltaStream. It was like,
Okay.
let's build something only for cloud, but now that we don't think about on-prem, we can take advantage of things that cloud offers for us. Let me
There
give you
you
an
go.
example.
Please.
Think about another service. Think about storage service. On-prem, people had to used to use HDFS for their storages.
You
Now imagine you're
made a
building
storage
something.
cluster. Yeah.
Yeah, you come up with cluster. You had to scale up, scale down. Think about like capacity and all of those things. Now, if you want to build something for cloud, if you want to do something for both cloud and on-prem, you kind of like have to build something that works in both environment. That's the limitation that you have to, because you can't diverge. The minute that you diverge, you have two different products, right?
Right. Right.
So a lot of systems, you can take that this HDFS and say I'm running a managed HDFS on the cloud, but user still has to deal with the concept of HDFS. How much capacity do I need? Do I have to provision a new cluster? And
Mhm.
I'm paying for that cluster the minute that I provision it, regardless if I am utilizing it or not in those. But if I just have to be concerned about cloud, and I said that okay, I give up on on-prem, but I'm going to build something for cloud that makes it extremely simple for user, takes away a lot of the complexity they don't have to deal with, and call it S3. You can
Right.
see the difference. Like S3 is cloud, Amazon takes care of all of the complexity, but it makes it extremely easy for user to use. You just deal with buckets and folders and files and read and write. All of the complexity is handled. There's no notion of cluster. It's like infinite resources. You just store as much as you want, you read as much as you want, and so forth. So what we were building for DeltaStream, or the idea that we started, and we have built something that we call it now S3 of stream processing, meaning that unlike systems like KSQL, that you have notion of cluster, you have notion of like provision a cluster as the first step, and then kind of like it's a managed thing. You take the on-prem system and run it on the cloud. We say that let's hide all of those complexity of clusters, nodes, and fault tolerance, and scaling up, isolation, and all of those things, and see what user wants. At the end of the user wants to run streaming queries, continuous queries, and materialized views, and these type of capabilities without thinking about provisioning a cluster. Oh, how big of a cluster do I need? Do I need this much cluster? Am I going to use more and later? Do I need 5 clusters instead of 2 clusters? Those kind of concepts can make it very complex. But think about S3 again. You don't think about those things. You just use it. So what if you can do the same thing for the stream? So that was the idea for DeltaStream. And that's the thing that we have built in the last 2 years, a little 2.5 years or so.
Okay. So let me just kind of reflect on that for a minute, because taking where you left off there, if I could imagine a conference talk on how S3 scales, like what that infrastructure looks like or something, that's a curiosity, right? That's a butterfly collection. That's a neat thing to look at, and I feel cool because I know now. But as an S3 user, there's an API. I do not need to know a single part of that, and I'm all about, as it were, collecting butterflies. That's fun, but that's not what S3 is. S3 is an API, and it's an infinity of storage.
You explained it very well, actually. I think I'm going to use this for my conversations too with copyright.
No, you got it. I actually got that from a linguistics podcast I listened to called Lexicon Valley. He talks about certain the history of words, etymology is not really that linguistically interesting. It can be fun. It's butterfly collecting. Anyway, I want to put some of these other pieces together because some of this is generational, right? You're coming in now. DeltaStream started in 2020 or 2021, something like that.
Practically 2021.
Yeah. So
and holidays, Christmas time of
there you go. Okay. Yeah. Hey, a lot of important projects have been rage coded over Christmas. That's the mythical origin story of Kafka. So, anyway, that's the cloud native era. Period. End of story.
Exactly.
You're completely justified in being a cloud first, and in your case, cloud only play.
Exactly.
And in Kafka's origins, the cloud was a thing. I mean, EC2, S3, more service, probably RDS. There are all kinds of, it wasn't the alphabet soup we have now, but the cloud was a thing in 2010, 2011. But it really was conceived as an on-prem single data center kind of beast. And then adapting it to the cloud is all this engineering and all this work and value, right? Because it's kind of horrible to operate. And now somebody doing that hard work gets to charge a margin for that because it's valuable work that they've done. The story with Pinot is similar, honestly. So StarTree having a managed Pinot, boy, you don't want to run it yourself. It's kind of hard to do. Here you go. And I part of what you're saying is giving someone the option of operating it themselves versus being completely cloud native involves architectural trade-offs. And those trade-offs do not redound to the benefit of the user or the simplicity or the performance of the system. You have to take hits. Now,
sometimes, yes, that's right.
Yes. As a cloud native service, you're still abstracting across clouds. Like you have to make it work in Azure, and that's its own story. But that's not. You're still blob stores are blob stores, and you just have more flexibility. That's kind of what I hear you saying, is that the value here is just going cloud native, and the trade-off is anybody who needs to run on-prem, they're not a customer.
Yes, we can't provide that for them, exactly.
But that's a shrinking piece of the pie. It'll always be non-zero, but it's getting smaller.
Exactly.
Yeah. All right.
One more thing, actually, another example on this. I don't know if of course, you're following Confluent. They have a new Kafka engine for their Confluent Cloud. That's another kind of like validation of like they had to kind of like come with a new product for the cloud, right?
Oh,
because you cannot just rely. If you look at the Cora that Jay announced earlier this year, I think, and they have actually a very nice paper on BLDB2 on that one. So it's reimagining or rebuilding Kafka for cloud, and comes back like the minute that you have this reimagining, now you have two products. You have Confluent Platform, for instance, for Kafka on-prem that user manages, and on Confluent Cloud, it's totally different. And we see this in different aspects. Like if you look at Databricks too, the cloud version is very different than the open source Spark, for instance. They actually rebuild everything from scratch. So overall, it's the progress that companies do when they go to the cloud. They start with the same product, but then they evolve to, okay, we need something totally different. Cloud only. Yeah.
Right. All right. This is great. Couple more things I want to cover. You folks, I think, just announced a Bring Your Own Cloud or BYOC product. If there's anybody who, I'm sure there are listeners who don't know what that means, tell us about that. Not to make this a commercial, but it's actually, in terms of cloud architecture, it's an interesting thing, and I'm glad that you guys just announced one. So give it.
Exactly. That's actually one of the, I would say, big announcements or differentiators, if you will, that we see in the market. And it's not just us. A lot of companies, I think it's StarTree too, they realize the importance of like security, regulated organizations that their need. And the idea is that a lot of organizations, especially more security-minded organizations, they are not comfortable with having their data leave their network, or they losing the custody of data, right? And sometimes it's not just under their decision; it's the regulated environment that they have to follow certain kind of like practices. And this, we started DeltaStream as a normal SaaS platform that we would operate everything, and we just connect to users Kafka, Kinesis, or other streaming storage systems and process data continuously, and all of things were fine. Providing
and
serverless
all of
experience.
the egress and ingress costs were also fine.
Well,
right?
Exactly. As long as there are ways to minimize them, like co-locating in the same region and same, like reducing this. But still, as you said, those are also things that to consider. But once we started talking to bigger customers, the bigger prospects that showing the demos and showing the platform, the first interaction was like, does my data leave my network or not? And the answer for a normal SaaS platform is yes.
Of course,
and
yes.
Honestly, that was a conversation stopper. Like they were like, our security team is not going to accept this. Anything that causes data leave our network, it's not going to be going fine with our security approval process.
Right.
So it was one of the, again, comes back like we didn't just started saying that, oh, this is cool. It was a need in the market. And again, I'm saying this because you can see the same thing that, for instance, StarTree and other data companies, they are seeing the need and they were providing this type of service. So we had to do this to be able to have those type of customers as we move forward. So we decided that, okay, it's time to provide a private SaaS or bring your own cloud. There are different ways of referring to it that guarantees that users' data does not leave their VPC or their network, while we are providing the same user experience, same serverless, as we discussed, cloud native way of running things that the user doesn't have to think about any of those complexities. So that was the trigger that caused us to kind of like provide this service. And as you said, we just announced it earlier this month in August, and we have seen a lot of interesting conversation based on the fact that now this unblocks that thing, that it is a orthogonal reason. Like any deal that you have, the security team should approve it. That's one of the approval processes that folks have. And it unblocks a big kind of like hurdle in adoption of SaaS by providing the private SaaS that guarantees your data does not leave your VPC.
Right. And I was going to ask, you clarified that for us. It's funny, we say it can't leave our network. And that used to mean servers and disks and wires of which you had physical custody. Now it just means your VPC, but still,
exactly,
they don't want it to. And it's exactly a security issue, and it's a billing issue, because now large chunks of cloud spend are negotiated at a high level, right? Like you might buy that on the golf course, as it were, and you don't want to now pay a SaaS vendor for a golf game they didn't play and cloud resources they're buying at potentially, if it's a large customer, a worse price plus their margin. The economics don't make sense. So there's a security issue and an economic issue.
This was a very important note that I forgot. Actually, you reminded me. Sometimes this actually becomes much bigger aspect, especially with this kind of economic situation. The savings that they can have with those negotiated prices that they have, especially for bigger organizations, that can actually be a very good incentive for considering
absolutely. And so the control plane stays in your cloud. Those are your resources.
Exactly.
Your data account, you buy them. Data plane lives for that. So that's the heart and soul of BYOC.
Exactly.
Final question. I would love for you to reflect on in this world of stream processing. You said tending more and more to say streaming analytics. There are the DeltaStreams, the KSQLs, the materializes. There are the streaming SQLs and the different approaches to that. I think yours is fascinating and I think compelling. And then there's a terminal database like Pinot. That's like, okay, Kafka, I'm going to consume all the stuff and put it in tables, literally store it in a different place. What's your take on why there are two? Like when one and not the other? How does the CEO of DeltaStream see this?
Yeah, I see this very much complementary technologies, meaning that you can think about them similar to, I'm not saying exactly, but similar to the way that you think about OLTP and OLAP. Mm-hmm. There are places that you use OLTP. There are places that you use OLAP. Case in point, for instance, analytic databases usually physically store data differently. Like they're columnar, the way that they index data is very different than the OLTP. So streaming kind of like sits in the middle, if you will. And usually you can see in a lot of use cases. Actually, I remember Pinot, and there was a paper from Uber a couple of years ago, I think it's Sigmo. They were showing that how they use Pinot and Kafka and Flink together to build real-time part of the business. And I think, as I mentioned, these are complementary technologies. You can see where you need stream processing, building those streaming pipelines, and process data in real time. And a lot of times, actually, we see that result of these streaming transformations, processing, ends up in systems like Pinot and serves user-facing analytics and, as you said, real-time analytics. So these are kind of like, again, systems that work hand in hand and kind of like complement each other for different use cases. But all of these use cases are the things that a business usually wants all of them. So you see that, for instance, as I mentioned in that Uber paper, all of these Kafka, Pinot, Flink work together to provide the bigger value for the organizations that we see.
My guest today has been Hojjat Jafarpour. Hojjat, thanks for being a part of the Real-Time Analytics podcast.
Thank you very much.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.